Hello and welcome. My name is Dinesh. Today we are going to talk about DMVPN Phase 2 with Ospf. So let's jump into this and start. We have some advantage and limitation of DMVPN Phase 2 when we configure with Ospf. So we'll be talking about advantage now. We have spoke to spoke tunnel between spokes. So if we are going to send traffic between red router and green router, we can directly send using a dynamic tunnel instead of directly going to hub and again from hub to green router. But in the case of OSPF, this will be again depend on what type of network type we are using here, because the scenario sometimes we use point to multi-point, the scenario sometimes we use point to point, and sometimes we use broadcast and non-broadcast. So all the network types, they have their own behavior in the network topology. So we will understand how can we see the traffic flow of these types of network. Tunnel mode multi-point, instead of giving static IP address of hub in tunnel destination, now we are saying here tunnel mode multi-point in all the routers, even hub or including spokes. Next hop can be updated again in DMVPN phase 2 with OSPF. Next hop can be updated and cannot be updated because the hub will update the next hop when we use the network type point to point and point to multi-point, but hub will not update the next hop when we use the network type like broadcast and non-broadcast. So it depends on the network type. Next hop is preserved. Again, if we don't want to update the next hop by hub, then we can configure a type of network. We call it broadcast network or non-broadcast network. Limitations we have here is summarization and default routing is not allowed at the hub, because in the database of OSPF all the routers must agree they have the same database. So all the devices in OSPF, they must keep the same database in the area. Again, it depends on the area. You may have number of areas, so area wise you can define, okay, in this area all the routers they have the same copy of the database. Point to multi-point networks give phase 1 traffic flow. So if we configure point to multi-point in DMVPN phase 2, that means you can see the traffic flow will be same as it is what you see in DMVPN phase 1. All the traffic will go via hub. So that's not the good solution. Let's understand how the traffic flow of the point to multi-point network and how the traffic flow is for broadcast network. So let's go to the configuration and understand the configuration part of DMVPN phase 2. So we have the topology for DMVPN phase 2. All the IP addresses are pre-configured. We need to configure tunnel here in hub and in all the spokes. So command to configure the tunnel, we have these commands. So first I would like to configure interface tunnel 123. Second, IP address of the tunnel. Third, I would configure tunnel source, that will be our NBMA interface. Tunnel key, most important if we want to configure. IP NHSRP authentication, simple text authentication here, but if we are using IPsec, we can see that will be encrypted in IPsec. Tunnel mode GRE multi-point, IP NHSRP map multicast dynamic. If we are receiving any multicast, we are gonna make multiple copies of multicast frame in unicast format and gonna send over the tunnel. Let's configure the same thing on another router, red router and green router. We can configure red router this time and can apply the configuration of red router. So again, this is spoke, but here we need to define same command as we define in hub. The same command is tunnel mode GRE multi-point, and rest command will be different because this is spoke, so it has to go through hub one time, Once the hub resolves the IP to IP, then there will be communication between spoke to spoke. So we need to define, whenever we have any multicast frame, where do we want to send, and whenever we want to send any type of message, where can we send to resolve the IP address. So we are defining here with map command, IP NHSRP map, private IP to public IP, IP NHSRP map multicast frame. I can send it to this public IP, which is my hub. Network ID 1, this is mandatory. IP NHSRP next hop, this command is also mandatory. We must define this command and MTU command. The last router for last spoke I can say is my router 3, which is green router, and I can say interface tunnel 1 to 3, tunnel source, tunnel IP, tunnel mode, GRE multipoint, and tunnel key, IP NHSRP authentication, simple text. We are defining all these, and we can see I define all the commands here. So DMVPN phase 2 is configured, and now we can configure Ospf in the DMVPN phase 2. So first configure hub router, and we can see what issue we can run into. Router Ospf network directly connected 168.1.0 area 0. The command network I need to give instead of giving network. So let me change the command. So network, and here it is. Let's configure another router. Router OSPF1 network 192.168.1.0 00025 area 0 network loopback, and network 192.168.25.0, and we can see the neighborship came up with hub. So neighbor adjacency is up now, but now we have one point-to-point connection between hub and red router. If another spoke comes in the situation, then there will be the different scenario, and we see what issue we are running into now after giving these commands. So network 192.168.1.0, loopback 3333, network 192.168.34.0, and here the issue started coming. If we can see, the hub router is running with the issue, and all the spokes also they are running with the issue. So what is the issue actually? The OSPF is not forming adjacency fully. OSPF is stuck in X start state. And why it happened? Because here what we can see is the tunnel mode. If we verify the tunnel mode, and it's very fast, we can verify this. If you want to verify, let me shut down one of the interface. I can shut down interface tunnel 1 2 3 shut down, so we can stop these messages. But we can see show IP OSPF interface tunnel 1 2 3 and see that do show IP OSPF interface tunnel 1 2 3 says the network type point to point. But in hub, if you see, we have two spokes, and network type point to point will not work out here because it can form neighborship only with one. So sometimes it's forming neighborship with red router, sometimes try to form neighborship with green router. So this is not happening at all, and continuously it's giving these messages. So what we can do is we can define network type point to multi-point. So if we see if we run point to point in this scenario, it's not gonna work. And the solution to do this, we have to go to all the spokes and hub. We need to define this command called IP Ospf network point to multi-point. So let's change this network interface tunnel 123 IP Ospf network point to multi-point. Enter. I go to another router, red router, and give the same command interface tunnel 123. I paste the same command here as well. Now all the devices, they have point to multi-point, and this is gonna work here. Let me give no shutdown command and verify. Wait for some time until the tunnel comes up and neighborship comes up. So tunnel came up, waiting for neighborship to come up, and we can verify this time. Show IP Ospf interface tunnel 123, and we see that point to multi-point, and cost of the tunnel is 1000 because very less speed. Timer is the most important. You can have point to multi-point on hub, and you can have point to point on red and green devices, but you must take care about timer value. Timer value must match in Ospf, otherwise they will not form any neighborship. So let's verify show IP Ospf neighbor, and they are in initial state, waiting for them to come up. So we can see now neighborship has come up. Both the routers 333 and 22, they are neighbor with this. If we verify show IP Ospf neighbor, this time they are in full state. We don't have any DR and BDR because this is point to multi-point. Let's verify something on router 2 and router 3. Before that we configure Ospf on router 4 and router 5 as well. So let me configure Ospf on router 4. So command is to configure here, enable, go to configuration mode, router Ospf 192.168.1.34, network 4444, loopback IP. Then I have to go to edge 2. Again I made the mistake, network, so that did not work here, but I can give here network, something which is extra here is this. So need to remove that and need to configure according to topology. Now we can configure router 5. Go to this device and say router Ospf 1 network 192.168.25.0 wildcard mask area 0 network 5555, and we can see all the neighborship has come up. All the neighborship we can verify. Come to this device, hub router is forming 2 neighborship. If I verify this device and say show IP Ospf neighbor, we have 2, but this side we can see DR and BDR concept in this scenario because we have Ethernet 0, 01 and 01. So the network type is broadcast, but in the tunnel network type is point to multi-point. But let's have a look at the traffic flow from green router going toward red router, and we verify that. So let's say trace route 2.2.2.2, because this is DMVPN phase 2 and they must make tunnel between them, but running with Ospf type multi-point, the traffic flow always will go via hub, even you are running phase 2. So DMVPN phase 2 with the network type point to multi-point in Ospf is not supported here. Even you try again and again, traffic flow is via hub. So it's like working like we are running DMVPN phase 1, and we can see the next hop is always updated by hub. In this case because this is point to multi-point network type. So if we see here, show IP route, and see the next hop value, show IP route Ospf, and see that next hop is updated by hub. This will always happen because we are running point to multi-point. So basically we don't run point to multi-point in phase 2. We can run the type of network which support DR and BDR concept. So we can change here the network type with broadcast and can configure network type broadcast in all the devices. So if I go to hub router and change this behavior, and I don't want this because this is not gonna work here properly. So we can go to tunnel and say IP Ospf network type, whatever network type, we can see broadcast, and I am defining here priority value 255 because I want hub to become DR and all the spokes to become BDR. Now that's most important thing, otherwise again you are gonna have a lot of issues in the Ospf network design. So better to make your hub router as a DR and all the spokes you make BDR. So go to this device, and how to make BDR, and BDR means I am making here this device will never ever become DR or BDR. So I am giving priority value 0, IP Ospf priority 0, and the same command I can apply on router 3. So we can see the behavior of point to multi-point topology, and we can see the behavior of broadcast network. IP Ospf priority 0, and let's see what do we have in hub. First verify the neighborship, show IP Ospf neighbor, and we can see both the spokes, they are DR others, and verify the network type, show IP Ospf interface tunnel 123. We can see the network type broadcast, and we have state this router is DR with priority of 255. There is no backup because all the routers are DR others, and by default timer value for this is 10 and 40. This time if I go to green router and verify the routing table, previously the next hop was updated by hub. This time we verify show IP route Ospf, and we can see next hop is preserved. But you see that we are learning 111, 222, 4455, but if I talk about 222, the next hop is 192.168.1.2. So if I want to send packet to this is my next hop. So hub must resolve the IP address for this particular IP. So green router is gonna send registration request for this IP. Hub will resolve the issue and will resolve, okay, you are looking for 192.168.1.2, then the public IP address is 200.0.0.2. This message we will learn from hub. Let's again trace route 2.2.2.2 and verify that, and it's taking some time, but the traffic will go one time. Generally it goes via hub, the next time it goes directly to the spoke. So it's going first to spoke, and it will go to red router. We can verify next this time. Let's see again, this time it must go to spoke directly. So we can see now there is a direct tunnel between green to red. If we verify show DMVPN, and we can see there are two tunnels, one is to hub and second is to another spoke. So that's really interesting, we can see in DMVPN phase 2. So what we can do is, let me send packet from 4 to 5 for verification the topology is working. 5.5.5.5 and it's working. Let's trace route how the traffic is going toward this device. So we can see the traffic first going to 34.1 green router, then it's going to red router, then it's going to another edge router 25.2. So in phase 1 you can run any type of network, it doesn't matter. You can run point to point, you can run broadcast or point to multi-point. The traffic will always has to go via hub. But in phase 2 it has to be broadcast or non-broadcast in order to preserve the next hop value, because if we run point to point or point to multi-point, that's not gonna work here. So in phase 2 the network type must be broadcast and non-broadcast in order to preserve the next hop value. Hub will, you can mean like hub should have priority higher and spoke they should have priority lower. So hub here is having 255 and all the spokes they have the priority value 0. That's why the traffic flow is proper here, and hub is controlling the control plane, it's not controlling the data plane. So I hope it has been informative for you, and thank you for viewing the video. Bye bye.